Hello everybody, welcome to Marketing Analytics course. This is Dr. Shagad Chatterjee from Vijisom IIT Kharagpur, and we are in week 12. We are discussing social network analysis. In the last two videos, I have discussed about what social network analysis is and why it can be applied, and in this particular session I will solve one case study to see that how this particular social network analysis can be applied in the real life situation. So, this particular case study was about a club. A club is where there are lots of people who actually take subscription and they use various facilities, they play games, so this basically entertainment is something that is major focus. Now, oftentimes entertainment does not happen alone, it happens in a group. So, it happens in a group means that if a set of people you form when you subscribe for a club and start going to that club, after some time you become a part of that particular social group, and whatever decisions you take, whether you will arrange a party or whether you will arrange a competition or whether you will do this and that, you will participate in some of the club events, are generally a collective decision. So, if that is a collective decision, then sometimes which club will you choose or whether you will be switching from this club to some other club is also sometimes a collective decision. So, this particular club all of a sudden, some club all of a sudden found that their organization's members are actually leaving the club in huge chunk. So, it is a churn, but unlike the churn in telecom or unlike the churn in let us say bank and etc., where churn is more of a personal decision, they know that this is a collective decision. So, they have to find out that who are the influencing persons in this social network who are driving this particular churn, whom I can actually connect, and then I can incentivize them or I can create certain kind of service recovery measurements or anti-churn measurement or switching barrier measures, so that I can stop them from churning. So, that was the major goal. So, they collected the data and the data looks like this. So, this is basically the text data, where there are basically if I am not wrong 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15, 16, 17, around 34. If I think this is half, so around 30, 34, 32 people were there, and you see that the diagonal elements are all 0. So, 0, 0, 0, 0, all the diagonal elements are 0, and these 4 means high strength, 5 means low strength, and these are bidirectional. So, actually not strength, they try to find out that how many people has talked with how many people. So, he just called the members and asked that in the last 1 month you have met or talked with which members and how many times. This much they have got the information. So, how many times you have talked with which member was the information, and from that information they try to find out, because all of these decisions have been taken in a small time frame. So, historically whom you are more connected with, I do not care. In the recent times, how many times you have talked with whom is something that is more important to understand. It can be also understood to find out that, let us say, if there is a mass bunking in your class, who has organized that mass bunking, you can find out from this kind of information. Who is the person who should be the class seer, can be found out from this kind of information. So, the first job is to set working directory to source file location, and then I will just read CSV. See, the separator is space and there was no header. So, header is equal to false. So, when I do that, that gives me a blank file with 34 observations as I told and 35 variables, 34 and 35. So, last one is NA actually, I do not know how that has been read. So, I will remove that. So, 35 observations. So, term matrix is minus 35, that is why the last one is, so 34 by 34, and then row names of term matrix and column names of term dot matrix are same. So, if this is V 1 V 2 to V 34, this will also be V 1 V 2 to V 34. So, that is something that I am ensuring here. And then I am calling a library called igraph. Now, igraph package is not there. So, I have to install this package. Okay, I can install it here itself. I can say install dot packages and then igraph. Okay, sorry. Fair enough, it has been downloaded. I will call this one. So, yeah. So, igraph is connected now. Now, I will create the graph. So, G is equal to graph adjacency and the term matrix is the input. Weighted is equal to 2, that means the 3 and 5 should be considered as weights, and mode is undirected because there was no direction. So, I created this and all the properties have been saved in this G. Now, I want to simplify the loops. If A is connected to B and B is connected to A and there is no it is a unidirectional sorry, it is bidirectional thing, then only the lower triangular matrix is enough because it is bidirectional. My connection with you and your connection with me are same thing here, and my connection strength with you and your connection strength with me is also same. If it is bidirectional and the length is the width is same in both the directions, then only one triangle, the lower triangle or the upper triangle is enough. So, that is what we are doing here. G is equal to simplify G means we are reducing the number of nodes in the number of paths in the graph that we have created. And then I am saying that V of G underscore level is V of G underscore name. So, what is V of G underscore name? These are basically the names of the nodes V 1, V 2 to V 34. I am saying that the labels means whatever should be written in the node when I pick the pictures. Right now, they are null, there is no picture. So, I will say that this is the V 1 to V 4. So, once I do that, when I draw this particular particular graph, it will look like this. Unless I do that, it will not look like this. So, let us try to make a case what I am trying to say, that now let us say this is one. If you do not do that, it will just create these nodes. It will not create any names. It will not give any names here. Now, after running this, this will be V 1, this will be V 2, this is called labels. These labels will be there, otherwise these values will be not there. So, that is what I am doing, I am ensuring it. So, and similarly V of G degree is degree of G. What is degree of G? So, each connection they are trying to find out how much is the degree. So, this is V 1 16, V 2 9, V 3 10 and etcetera. So, V G degree is also something that I am trying to say, that how fat or how small these particular nodes will be. So, V 1 has 16 connections total connection strength is 16. So, that is why it is 16. V 2 has, how will I know that? If you just check the term matrix, V 1 4 plus 5 9 plus 3 plus 3 plus 3. Okay, so, this is actually more than 16, just let me check what this value is. So, term matrix, sum of term matrix and then the first row is 42. Okay, then that is not the value. So, sum matrix term greater than 0 is okay. So, how many guys he is connected with actually? V 1 is connected with, that value is 16. So, V 1 is connected with 16 guys out of this 34 guys, V 2 is connected with 9 guys, V 3 is connected with 10 guys. So, the more the connection is, the fatter will this look like. So, this will be bigger if V 1 is 16, this will be smaller, this will be of this size, this will be of this size if their connection is much higher. So, depending on the depending on the number of connections they have, the node will be bigger or smaller. So, that is something that we are ensuring here. So, by running this line I am ensuring that. Then I will plot this. So, some set sheet, and then layout 1 is there are different methods of laying out. So, I am using the Fucherman Reingold layouting. So, if I run this and then plot the layout, I get this kind of a view. So, it is saying clearly, if you check carefully, that these two guys are more central, V 3 and V 4, and then comes probably even I do not know this V 14, this person is also V 2, V 14, these people are also connected, but not I cannot say that who is the major person till now. I cannot say that in a better way. So, I will try to get another plot. So, let us say if I remove this and I plot Kamada Kawai plotting. Kamada Kawai plotting looks like this. The same thing they have plotted with the different tension and different visuals. This is further not better. Okay, this I cannot say that who is the person who is responsible. So, I can do a TK plot with Kamada Kawai, which is an interactive plot which looks like this, and here what I can do is I can select all the vertices and right click on any one of the vertices, and vertex color I can change it to white. Now, everybody is same, and then I can select all the vertices and vertex size is let us say I make it a little bit bigger. Okay, so, it becomes smaller actually. So, select all the vertices and then vertex size I will make it a little bit bigger. So, now I can see this, fair enough. Now, what will I do? I will fit the screen. Now, if you can see carefully that see this person V 13 is V 34 is most connected and V 1 is also connected, and V 20 is a person who is in between, not so much. V 29 is also not so much, V 31 okay, not so much. So, V 34 and V 1 and these are the two persons who creates most amount of connections. So, probably these are the two persons who have made this kind of a problem. Now, if I just say that all edges and right click on the edge, and edge width will be okay, edge width will are same here. So, why do not I try out another one, like let us say I try out this this one which is Fucherman Reingold as I was doing. Here also I can say that 34 is most connected, fair enough, 33 is less connected than 34, and here I can, so I can specifically see there are two groups of people. One group of people are this who are more connected with 33 and 34, and another group of people is this which is more connected with V 1, and in between probably there is V 3, not V 3, V 3 and V 9 are the person who are lying in between these two groups. So, if I by chance cut V 3 or V 9, this particular place I can create a cut, this guy I can, if I vanish, then there are lots of less connections will be there from this group and that group. So, this is something which is an interesting insight for these marketing managers. Now, what they later do, I want to make it a little bit better looking. So, to make it a little bit better looking, I can say that the level will be based on the degrees, the level color can be changed and the width can also be changed. So, this is something that I am putting up. Just 1 minute. Okay, so, this is something that I have to run and then I can run this, fair enough. And then if I now try to plot, you will see that not only I am getting the V34 and 33 and V1, the size are bigger because as I was telling, I can specifically see that which one has higher things and which one is lower. I can also plot in this interactive plot. The interactive plot will also try to, so if I just select all vertices and make the color white, and then if I just lay out with this one, I can still say that see 33, 34 is coming very big and V1 is coming. So, I think these two guys are most important guys, 33, 34 and V1, and V3 is a person who is in between, who is also trying to connect between these two people, and I have to find out that which group is leaving. If this group is leaving, then 33 and 34 are more important. If this group is leaving, then V1 is more important. If these guys are quarreling, then V3 is most important. So, this is the social structure of the club participants, and if there is lots of churn happening, we as marketing manager of this particular club has to identify that whom I can incentivize to reduce the chances of churn. In this particular condition, it is V33, whatever be this person, V33, V34 and V1, these are the persons who can create a difference in this churn management kind of a scenario. So, that is how I can say that we can apply social network analysis in a situation. This is more of a exploratory analysis technique. This is not majorly a I would say very hardcore machine learning kind of technique, but from here I can find out the centrality, the I would say cohesiveness and various other measures that are there about structure, social structure, and from there we can find out that how that impacts the centrality or social structure or cohesiveness impacts the chances of reneging or staying in the club or not. So, that is all for this particular case study. We will be doing another case study in the next video, and I will meet you in the next video. Thank you very much for being with me. See you in the next video.